Svima. Samo par riječi na početku na hrvatskom, a onda ćemo preći na engleski. Tako smo se dogovorili s našim gostima i zahvaljujem na razumijevanju radi toga. Dear all, dear distinguished guests, ladies, gentlemen, friends, it's very nice to see you here, and I'm Josip Patalić, I'm your host today. I'm so happy that we gathered again, like we did once on the field and in offices after 2020 earthquake. I think this is most of earthquake engineering community in Croatia, and I am so happy about it. This event is one part of continuous process what we are doing after earthquake. We are trying to raise seismic risk awareness all the time. This is one of the bricks, and we will never stop talking about earthquakes. Today we have on menu few opening remarks. It is 3+1, I am that one. 4 lectures, 4 closing remarks, maybe plus, maybe somebody of you will interrupt, and I think we'll be over to 4 p.m. I hope so. You got all data in your invitation to this event, and I'm trying to be short in my 4 minutes. And at the beginning, I will call my vice dean, my friend, my future dean, to say some welcome words for all of you. And please don't mind. But before that, please, one big applause for our guests and for all of you. So see you, welcome here.
So thanks, Josip, for kind introduction. I will say a few formal words and welcome you at today's seminar. So it is my great pleasure to have this opportunity to welcome you on behalf of the Faculty of Civil Engineering at Build Back Better Together seminar. First of all, I would like to express my sincere gratitude and warm welcome to His Excellency Iso Masato, the Ambassador of Japan to Republic of Croatia. I have to say that His Excellency Mr. Masato initiated the organization of this seminar and made possible the visit of distinguished Japanese lecturers that will present their presentation to us today. So I would also like to welcome first Mr. Ivan Paladina, the Minister of Physical Planning, Construction and State Assets in Croatian government. Mr. Željko Uhlir, State Secretary at Ministry of Physical Planning, Construction and State Assets. Mr. Tomislav Petrinec, Director of the Directorate for the Protection of Cultural Heritage. Mr. Petar Šokić, Head of the Department for Capital Investments and Accounting at the Croatian Ministry of Science and Education. Mr. Gordan Hanžek, State Secretary of the Central State Office for Reconstruction and Housing Care. Mrs. Kristina Martinović, representative of the City of Zagreb and head of the Department for Safety and Prevention at City Office for Local Self-Government, Civil Protection and Safety. Professor Bojan Baletić, Dean of the Faculty of Architecture at the University of Zagreb. Professor Almin Đapo, Dean of Faculty of Geodesy at University of Zagreb. Mrs. Nina Dražin Lovrec, President of Croatian Chamber of Civil Engineers. Mrs. Rajka Bunjevac, President of Croatian Chamber of Architects. Some of the people I had on my list I think didn't show up, so I will just welcome also the representatives of the World Bank and the representatives of the European Bank for Reconstruction and development. Of course, welcome goes to all the professors, colleagues, maybe students that are here with us. Thank you, everybody, for coming to this seminar. I also have to pay my special respect and welcome to the distinguished guest lecturers. First of all, this is Professor Emeritus Seiichi Fukao from Department of Architecture and Building Sciences at Tokyo Metropolitan University. Mr. Kimihiro Hashimoto, the President of the Building Center of Japan. Mr. Hirofumi Hama, Senior Executive Officer at External Relations Department of Daiwa Housing Industry. And Mrs. Ritsuko Yamazuki Honda, the Deputy Director General of National Research Institute for Earth Science and Disaster Resilience. So, all of us that are here today are in some way involved in the reconstruction of the damage caused by two earthquakes from 2020 in Zagreb and Petrinja. Also, all of us are aware of the challenges and difficulties that we are facing in this process. We all know also that Japan is one of the most earthquake-ready societies in the world, and we must and we should look up to Japan's experience, organization, and achievements in battle with the earthquakes. The aim of today's seminar is to share knowledge and learn from Japan's experience in order to help Croatian experts and administration to overcome some of the challenges that we are facing. We live in a seismically active region, and we need not only to build earthquake-resistant buildings, but we also need to continuously increase the earthquake awareness and preparedness of the general public. As engineers, we also have to provide assistance to the government in increasing the resilience of our society in event of future disasters. I also have to emphasize that our faculty and the Croatian Center for Earthquake Engineering has a very good collaboration with Japanese embassy in recent years, and I hope that this collaboration will be even better in the future. I'm sure that today's short seminar will be fruitful, with interesting presentations, stimulating discussion, and knowledge exchange. Thank you very much, and I wish you a pleasant afternoon at the Faculty of Civil Engineering.
Thank you, Domagoj. I'm sure he will be a great dean, and we are so proud of him, and I wish you good luck next 2-4 years. Like you said, Japan Embassy played an enormous part in organization this event, and they were so full of understanding and trying to not waste our time and not bother too much. And I have to say, I enjoyed every moment of this organization, and Your Excellency, you have to be proud of all of them. Your Excellency, Mr. Iso Masato, Ambassador of Japan to the Republic of Croatia, please can you share a few words with us?
Thank you very much. Dobar dan svima. His Excellency Mr. Ivan Paladino, Minister of Physical Planning, Construction and State Assets, Mr. Gordon Hanjek, State Secretary, Central State Office for Reconstruction and Housing Care, dear Professor Domagoj Damjanovic, Vice Dean and Dean Designate of Faculty of Civil Engineering, University of Zagreb, and dear Professor Josip Atalic, Head of Croatian Center for Earthquake Engineering. distinguished lecturers from Japan, dear participants present and online. It is my great pleasure to join this seminar, Build Back Better Together, supporting the post-earthquake reconstruction through Japan-Croatia knowledge exchange. As cooperation partner of the event, I would like to express my sincere appreciation to Croatian Center for Earthquake Engineering, Faculty of Civil Engineering, and the Building Center of Japan for organizing this event. I also express my sincere gratitude for the attendance of high-ranking representatives from the government, international organizations, and academia. Your presence proves that Croatia is keen to share experiences of post-earthquake reconstruction with Japan. After two large-scale earthquakes in Croatia 2020, my predecessor, Misako Kaji, took swift initiative in organizing a series of events to share experiences and knowledge of building back better. In February and March last year, our embassy and the Croatian Ministry of Physical Planning, Construction and State Assets have jointly organized an online seminar. In October of the same year, a Japanese company donated and installed early warning earthquake detectors in cooperation with UNESCO, Ministry of Culture and Media, Ministry of Interior, and Ministry of Science and Education. In March this year, a leading think tank of Croatia, IRMO, held a conference entitled Towards a Resilient Society, Croatia and Japan Cooperation, in which Professor Hayashi, President of National Research Institute of Earth Science and Disaster Resilience, NIEDO, discussed with Croatian specialists. Today, I am very delighted and honored that 4 highly esteemed Japanese experts in disaster risk reduction and post-earthquake reconstruction from public, academia, and private sectors have come to Croatia to further exchange knowledge and expertise with Croatian counterparts. I sincerely hope that today's seminar would serve to deepen the understanding of the Build Back Better concept and to bring new ideas and opportunities for concrete cooperation. I also hope that it will further strengthen the friendly relations between Japan and Croatia, which will mark the 30th anniversary of the establishment of diplomatic relations next year. Thank you very much for your kind attention. Hvala vam.
Thank you, Excellency, on kind words. Domagoj mentioned that we have in the room representatives of several ministries. Few of them are incognito here, and we are total, I think, 50, including YouTube online stream. We are trying to help with our knowledge, but the greatest burden is on them and responsibility. Maybe the greatest weight is on Minister Paladina's shoulders, Ministry of Urban Planning, Construction and State Assets. He has so many challenges in that ministry without earthquakes, but with earthquakes, I think it takes great courage to take all this. I hope this event will help a bit, but please, can you share a few thoughts with us, Minister Paladina?
Thank you, Josipe. I don't know if I could say 4 kind words. Dear Mr. Ambassador, ladies and gentlemen, I would like to express my appreciation for organizing this seminar, and thank you, of course, for the invitation. I'm always glad to participate in seminars and conferences that can contribute to improve reconstruction and rebuild process. As we all know, a series of two devastating earthquakes caused significant damages on more than 65,000 buildings in earthquake-affected areas. As a result, we currently have around 30,000 construction and rebuild. Apart from the large number of earthquake-damaged buildings, we are faced with also for us at the ministry. Japanese knowledge and experience helped us in understanding the reconstruction and rebuild process, especially the newest methods of earthquake-resistant construction. We implemented this experience in the Croatian reconstruction and rebuild model, and this conference will have importance in future application of highest quality experience and expert knowledge. So once again, thank you for all the help you've given us so far in this process. I'm looking forward to hearing all your opinions, advices that will help us in future. Thank you very much.
Okay, we are now going in a lecturing part. Just few infos before. We have, like I mentioned, 4 lectures. After every lecture, we have question and answers, and you are welcome to make ones. In the middle, we will have a short break, 20 minutes, and closing remarks on the end. Okay. On the beginning, our first lecturer is Ishii Fukao, Professor Emeritus on Tokyo Metropolitan University. In invitation was his remarkable CV, and I will point out several rewards. He will have longest lecture with overall perspective of Japanese fight against earthquakes through history of building engineering and building code in Japan, focused on seismic design. Please, floor is yours.
May I use this microphone? She will use this one. Okay. So, good afternoon, ladies and gentlemen. My name is Seiichi Fukao. I'm not so good at speaking English, so today I will speak in Japanese, but a very capable interpreter, Yuko, will translate my lectures. So, my name is Seiichi Fukao. このような機会をいただいたことを大変感謝いたします。
Thank you very much for giving me this opportunity to speak to you.
地震とその被害に対してどのように向き合ったらよいか、経験を共有させていただければ幸いです。私からはそれに関しての総論をお話しします。
I'm very happy to share with you our experience of earthquakes and the learnings that we gained from them. And my presentation today will be a general, pretty high-level one.
地震の被害の経験から何を学ぶか、そしてそれを将来にどう生かすか、それが、今日のお話の目的です。日本でそれがどのようになされてきたかをまずはご紹介したいと思います。
So the topic of this presentation is what we should learn from the earthquakes, and also, what actions we should turn them into. And then first, I'd like to introduce you how we actually did the process so far.
そしてそのことによって日本の建築に関する法律、特に構造設計の仕方に関する法律がどのように変わってきたかもお話ししたいと思います。
And at the same time, I'd like to provide you how we have developed our the administrative system, especially the legal framework for seismic design.
日本では1868年に政治体制が大きく転換し、近代化の道を歩み始めました。 それまで300年近く外国との接点を小さく絞っていたんですが、建築の分野でも急速に欧米の技術を導入し始めました。それまでは日本の建築はほとんどが木造だったのですが、レンガ造なども導入され始めました。150年前のことです。
Japan had a huge shift in the political system back in 1868 and started its journey of modernization. And up until then, the country had a very small window to foreign countries for nearly 300 years. Once we opened, Western technologies rushed in, including its architecture. And the brick construction came to Japan, where most buildings had been built in wood prior to that. It was about 150 years ago.
日本は自然災害が多発する国としても知られています。地震は昔から頻繁に起こっていました。その記録も文書の形では残っています。台風も夏から秋にかけて日本を襲います。台風圧設計も日本では重要です。津波、洪水も起きますが、今日はお話ししません。また、ほとんどの建築が木造でしたから、過去数百年にわたって都市大火は頻繁に起こっていました。したがって、レンガ造などの耐火建築の技術は日本にとって近代化の象徴だと思われました。
Japan is known as a country prone to natural disasters. From ancient times, we had so many earthquakes, and the seismic records are left in the document. And typhoons hit Japan from summer to autumn, making wind resistance very important for structures. And tsunamis and floods are also well known, but I will not touch on them today. And we built mostly with wood, and naturally urban fires are very common. In that sense, fire preventive construction like brick masonry was almost a symbol of modernization in people's eye.
日本に最初に設置された大学、現在の東京大学では、1879年に建築学科の最初の卒業生4人が生まれました。後で触れますけれども、その建築学科が工学部に設置されていたことが日本の特徴でもあります。彼らは木造についてはほとんど学ばず、西洋流の石造やレンガ造による建築の作り方を学びました。143年前のことです。
The first university ever established in Japan, today's University of Tokyo, produced its first graduate in School of Architecture in 1879. And please see the slide for them. Interestingly, architecture belonged to the Department of Engineering, showing a uniquely Japanese approach to architecture. The students learned virtually nothing about wood, but instead studied Western-style architecture, such as stone or brick masonry.
レンガ造が日本で建て始められてしばらくして1891年にマグニチュード 8.0 と言われているノーブ地震と呼ばれる直下型の地震が日本の中央部を襲います。
And sometime after brick buildings appeared across Japan, an epicentral earthquake called the Nobi earthquake occurred in central Japan.
この地震では欧米の技術で建設された鉄道の橋が崩壊し、レンガ造の建築も破壊されました。その結果、耐震構造を研究しなくてはならないということになりました。地震の被害がきっかけとなるということは残念なことですけれども、とても大切なきっかけとなったわけです。翌年の1892年には震災予防調査会という研究組織も設立されました。
In this seismic event, railroad bridges built using Western technology collapsed, and brick buildings were also destroyed. As a result, Japan felt the need to study seismic structures. The fact that it was prompted by the earthquake devastation was unfortunate, of course, but we can also say the experience presented a valuable opportunity to learn. In the following year, 1892, a research organization called the Earthquake Disaster Prevention Research Society was created.
建築物の耐震設計法に関する研究も進められました。サンフランシスコの大地震の地震調査なども行われて、 1915年頃には研究がまとめられます。今から100年ちょっと前です。
So research into seismic design methodology for buildings was started as well. Damage surveys were conducted, including for the San Francisco earthquake also. These studies were consolidated into theoretical work around 1915. It's about 100 years ago.
東京大学の教授だった佐野俊方などが中心となって、地震力を水平力とみなして構造計算に組み入れることが始まります。いわゆる静的火力であって、振動特性を考慮したものではありませんでした。具体的には建物の自重の 0.1 倍とか 0.2 倍の水平力をかけて破壊しないようにするというものです。動的な解析が行われるのはかなり時代が下ってからのことです。
Professor Toshitaka Sano, University of Tokyo, led the movement to incorporate the seismic force as horizontal force in structural calculations. It was still a static load only and didn't consider any cyclic properties. It was limited to design a building not to collapse under a lateral load of 10 or 20% of its own weight. We had to wait for some time before dynamic analysis to begin in Japan.
1921年に市街地建築物法というものが制定されます。これは日本における初めてのビルディングコードでした。ほぼ100年前のことで、昨年日本ではそのことを祝う式典が行われました。1924年にはその中に耐震設計に関するコードが入れられます。これは世界で最も古い耐震設計法に関するコードです。
In 1921, the Urban Building Law was enacted, which was the first building code in Japan. It was about 100 years ago, and that is why we had a special event commemorating the centennial of the first building code last year. In 1924, the code introduced seismic design requirements, the world's first or oldest code provisions for seismic design methodology.
ただ、この法律は市街地の建築が対象であって、郊外に立つ木造住宅などは対象になっていませんでした。この時に構造種別ごとに法体系が整備されました。木造、鉄骨造、鉄筋コンクリート造に分けて法体系が整備されました。このことは2000年まで続きました。
However, this law was for urban buildings only, and suburban wooden houses were not in its scope. At the same time, the code was organized by the construction type. Legal requirements were written separately for wood, steel, or RC construction, and this system remained in place till 2000.
この頃、日本では建築物の高さが31メートルまでに制限されていました。地震に対して危険ではないか、火災に対しても問題ではないかということだったのでしょう。もっとも1644年に建設された当時の五重塔は高さが 54.8 メートルであって、現在でも壊れないで立っています。木造建築は意外に長持ちするのです。
In those days, the building height was restricted to 31 meters at maximum. I assume people worried about the risk of earthquakes and fire on high-rise buildings. As a matter of fact, the 5-storied pagoda of Toji Temple, built in 1644, is 54.8 meters tall and still standing solid. Wooden structures are pretty strong against earthquakes.
この高さ制限は1970年まで続きました。約50年前までです。構造計算に関する考え方に大きな変化があったためで、その少し前から特例措置によって超高層ビルが建設されるようになりました。現在は高さ60メーターを境に耐震設計法が異なっています。
This 31-meter height limit was in place till 1970, about 50 years ago. A major shift in the approach to structural calculations terminated the restriction. But even before 1970, skyscrapers started to show up in Japan, taking advantage of a special permit system. Today, we use different seismic design methods between buildings 60 meters or higher and lower than 60 meters.
1923年に関東大震災と呼ばれる大地震が東京を襲いました。ほぼ100年前のことです。マグニチュード 7.9 の直下型地震と言われています。
In 1923, Tokyo was hit by so-called Great Kanto earthquake. It occurred approximately 100 years ago and was reportedly an eccentric quake at magnitude 7.9.
ちょっと加えます。その1年後の1924年に先ほど申し上げた耐震に関する法律ができたわけです。
And remember that seismic code, the first seismic code I mentioned, and that was introduced 1 year after this earthquake in 1924.
この地震ではレンガ像などに大きな被害が出ました。その頃建設が始まっていた鉄筋コンクリート像は比較的健全でした。鉄骨像にもかなりの被害が出ました。そして鉄骨鉄筋コンクリート像という日本独特の構造が被害が少なかったんです。この後日本では高層の建物は鉄骨鉄筋コンクリート像で建設されるようになって1970年頃に超高層ビルが鉄骨像で建設されるようになるまでその傾向は続きました。
In this seismic event, brick buildings received extensive damage, but reinforced concrete buildings, which started to appear around that time, withstood the shock relatively well. Steel buildings were also hit hard. A uniquely Japanese construction, steel reinforced concrete construction, or SRC in short, had little damage from the earthquake. That is why SRC became the construction method for high-rise buildings in Japan until steel construction became the mainstay of super tall buildings around 1970.
関東大地震では浅草と呼ばれる東京の下町に眺望のために建設されていた凌雲閣という建物が崩壊しました。12階建て高さ52メートルのレンガ像で1890年に竣工したものでした。
The Great Kanto earthquake destroyed this building called Ryōunkaku, which had been built as a scenic viewing tower in a downtown area called Asakusa in Tokyo. It was a 12-story brick building, 52 meters tall, and completed back in 1890.
関東大地震の直後に帝都復興院という復興組織が設立されました。後藤新平という東京都知事を経て内務大臣になった人が総裁になりました。また翌年の1924年には内務省によって同潤会という組織が設立され、1925年から1934年まで集合住宅の建設が行われました。その後も木造住宅の建設は同潤会によって続けられました。
Right after the Great Kanto earthquake, an organization for recovery efforts was created called Teito Fukko-in, or Imperial Capital Reconstruction Institute, headed by Shinpei Goto. Mr. Goto had been the governor of Tokyo and was the minister of the interior at that time. In 1924, a year after the quake, the Ministry of the Interior founded an organization called Dojunkai, which constructed the multi-residential buildings from 1925 to 1934. The construction of wooden houses continued on at the same time.
また、同じく1925年から復興小学校と呼ばれる小学校が鉄筋コンクリート像で建設されました。その数は117校に及びます。
From 1925, the same year, elementary schools were reconstructed using reinforced concrete and amounting to 117 schools in total.
第二次世界大戦の間は日本中で建設は停滞します。また終戦直前の1944年には昭和東南海地震というマグニチュード 7.9 の海洋性の巨大地震が、そして終戦直後の1946年には昭和南海地震というマグニチュード 8.0 の海洋性の巨大地震が起きますが、戦争によりあまり記録が残っていません。戦争によって建設のみならず研究活動も停滞したんです。
During the Second World War, construction was mostly halted across Japan. In 1944, just before the end of the war, a huge submarine earthquake of magnitude 7.9, called the Showa East Nankai earthquake, occurred, and shortly after the war, in 1946, did again a submarine megaquake of magnitude 8.0, called the Showa Nankai earthquake. But because of the war, not much record was left for these two events. So the war actually stagnated, not only in construction, but also in research activities.
戦後すぐに戦災復興が始まります。最初は本格的な建設はあまり行われませんでしたが、1950年に現在まで続く建築基準法が制定されました。70年ほど前のことです。実は私は1949年生まれですので、日本の建築基準法より一つ年上です。
When the war ended, reconstruction activities started immediately. Initially, there weren't many full-scale projects, but in 1950, the Building Standard Act was introduced, and it remains an important piece of legislation to today. It was 70 years ago. I was born in 1949, so I am 1 year older than the Building Standard Act. Well, ladies and gentlemen, you have to say that if professor looks younger, or about the same?
1960年頃には建設が本格化します。第二次世界大戦で日本の市街地のかなりの部分が爆撃による火災によって消滅しました。そのため、都市の不燃化を図るために鉄筋コンクリート像などの耐火建築による建設が奨励されます。ところで、日本の鉄筋コンクリート構造は柱張り構造が多いことが特徴です。木造建築の長い歴史があり、開口部を大きく取ることが多いためでしょう。
Construction was in full gear by 1960. And during the war, significant portions of urban areas in Japan were lost to fire due to bombing. That urged the government to promote and encourage fire preventive construction, such as RC, aiming for non-combustible cities. By the way, I'd like to point out that the reinforced concrete construction in Japan is mainly of post and beam construction. I believe that it comes from the fact that we tend to have large openings based on our long tradition of wood buildings.
Left side. 一方、1970年頃までは集合住宅は壁式構造で建設されていました。Right side. エレベーターを設置しない4階、5階建ての集合住宅が1960年から1975年頃にかけて数多く建設されました。それらの耐震性はかなり高いものでした。
On the other hand, multi-residential buildings were built in bearing wall construction, and you see it on your right. And 4 or 5-story walk-up buildings were built in large numbers from 1960 to 1975 for housing. These buildings featured good seismic strength.
1968年に十勝沖地震と呼ばれる地震が起きます。マグニチュード 7.9 と言われています。この地震では北海道の南部や東北地方で鉄筋コンクリートの柱張り構造の大学や学校建築に大きな被害が出ました。このことは建築構造学の分野に大きな衝撃を与えました。そしてさまざまな研究が進むことになりました。
In 1968, there was the Tokachi-oki earthquake of reportedly magnitude 7.9. Post and beam RC school and university buildings received significant damage in southern Hokkaido and the Tohoku regions. It sent a shockwave through the discipline of structural engineering and initiated a broad range of new studies.
1971年、3年後には、建築基準法施行令の改正が行われます。施行令というのは法律本体に付属するもので、具体的な設計方法などを規定しています。また、日本建築学会が鉄筋コンクリート構造計算基準を改定しました。日本建築学会というのは日本の建築学の研究者の集まりで、会員数は約3万6,000人います。その中には構造技術者も含まれますし、建築設計者、建築家も所属しています。
In 1971, the Enforcement Order of Building Standard Act was amended. You know, enforcement orders belong to their governing laws, respective governing laws, and their order prescribes special design methods and other requirements under the BSA, Building Standard Act. In addition, the Architectural Institute of Japan, or AIJ in short, revised its RC structural calculation standard. The Architectural Institute of Japan is an organization of Japanese researchers in architecture with approximately 36,000 members. The membership includes structural engineers, designers, and architects.
このように地震被害の経験と学術的研究、工学的研究、そして建設による経験によって耐震設計法、耐震基準は進歩を遂げてきました。しかし、建築物というものは長い間経ってますから、古い基準で建設された建築物の耐震性が問題となります。1977年には既存建築物の耐震性評価に関する基準とガイドラインが制定されました。
So our seismic design methods and the seismic resistance standard have evolved thanks to our own experience of earthquakes and their impact, scientific and engineering studies, and actual construction. Well, buildings do last for a long time, right? And the vulnerability of old buildings constructed under an outdated building code became a matter of concern. Thus, in 1977, the standard for seismic evaluation of existing buildings and guidelines was introduced.
その直後の1978年には宮城県沖地震というマグニチュード 7.4 という地震が仙台や福島を襲いました。福島という地名は皆さんもご存知かもしれません。私は1977年に東京都立大学の助教授に就任していて、すぐに現地に調査に行きました。鉄筋コンクリートの柱張り構造に被害がたくさん見られました。
Right after that, an earthquake of magnitude 7.4, called Miyagi-ken Oki earthquake, hit Sendai City and Fukushima in 1978. And Fukushima may be a very well-known name to you. I was appointed as assistant professor at the Tokyo Metropolitan University in 1977, so I was immediately dispatched to survey the situation. I observed the damage to the post and beam structures in reinforced concrete at that time.
プレキャストコンクリートのカーテンウォールが落下しています。この建物は鉄骨造です。この頃から構造躯体だけではなく、非構造部材の耐震性も考えなくてはいけないと言われるようになりました。
You see, the curtain wall made of precast concrete have fallen off. This building is of steel construction. It was around this time that some started to say the seismic strength of non-structural members needs to be considered in addition to structural members.
これらの地震被害の経験とそれに対する学術的工学的研究の成果として1981年に新耐震設計法と呼ばれる耐震設計法耐震基準が法律として訂正されました。ほぼ40年前のことです。この法律はいまだに新ニューと呼ばれています。そろそろ新と呼ぶのはおかしいんですけれども、この基準によって巨大地震では多少の被害が出ても建築物が崩壊することはなく、人命は守られているということになりました。その後の何度かの地震によっても確認されています。それでその後は大きな改正は行われていません。ですのでいまだにニューなのです。
Studies of these earthquakes culminated in the establishment of the new seismic design code, or we call it the Shintaishin Sekkeiho, as a law in 1981. It was 40 years or so ago, but it is still called new, even though it is 40 years old. The law is now widely recognized as a pillar of safety of buildings in any seismic event. If a building is built to this code, it may be damaged, but will not collapse. The new code prevents a fatality from building failures. The code has been validated through a number of earthquakes. That is why no major revisions have been made on this, and that is why it is still a new code.
ただ、この時点では木造建築の耐震性向上としては十分でなく、その後木造に関しては改定が行われています。また、超高層建築物の長周期地震動への対応が十分ではないのではないかということになっています。
The code, however, didn't offer sufficient level of earthquake resistance to wooden buildings, and its provisions concerning wood construction were later revised. Now, the issue of the code is that its coverage of long-period seismic motion may not be sufficient for super tall buildings.
その後、1985年には、当時の建設省建築研究所などが中心になって、地震直後の建築物の損害状況を調査し、近寄ったら危ない建物かどうか、多少壊れていても安全かというようなことを判定して表示する応急被災度診断という技術が開発されました。
In 1985, the Building Research Institute, under the Ministry of Construction, led the development of the post-earthquake quick inspection of damaged buildings, a new technology and program where buildings are surveyed for damage right after an earthquake. Assessment is made if the building is damaged to the extent it is hazardous and should be off-limit, or if it is safe, even if showing some visible damage, and the building will be marked accordingly.
そして、1991年には応急被災度判定の基準が適用されるようになります。赤、黄色、緑という色は、分かりやすいですね。これを建物に貼り付けるわけです。
In 1991, the standard for damage classification of buildings and guidelines for restoration was implemented. Don't you agree that the color coding of yellow and red, yellow, and green is very easy to understand? So these stickers will be placed on buildings.
1995年に兵庫県南部神戸市を中心にマグニチュード 7.2 の地震が起きます。過密に建設された都市を襲った現代の地震として衝撃的なものでした。土木構造物やインフラストラクチャーに大きな被害が出ました。そして6000人を超える人々が亡くなりました。また密集した木造家屋の火災も悲惨なものでした。27年前のことです。
In 1995, a magnitude 7.2 earthquake hit South Hyogo, including the city of Kobe. It was a modern-day seismic event, physically and figuratively, striking a densely built-up metropolis which shocked the nation. Infrastructure and the civil engineered structures were directly hit. More than 6,000 people lost their lives. It was tragic to witness fires consuming areas crowded with wooden houses. Oh, it has been already 27 years since then.
建築物の被害について言えば、1981年の新耐震設計法以前の建物に被害が多く、それ以前に建設されたものは比較的健全に残りました。住宅の被害は全壊が10万戸ほど、半壊が10万戸ほど、部分的な被害を含めると40万戸を超える住宅が被害に遭いました。また建築物は5000棟近くに被害が出ました。
Damage was mostly found among the buildings constructed before the new seismic code of 1981, and those built after the law were left relatively intact. For detached residential houses, more than 400,000 units received substantial damage, including 100,000 totally collapsed, 100,000 semi-collapsed, and the rest partial damage. And nearly 5,000 residential or multiple residential buildings received damage as well.
この地震ではピロティを持つ建築の被害が特徴的でした。鉄筋コンクリートの柱が地震動によって破壊されて、上階の荷重を受けきれなくなったんです。ザグレブにもル・コルビュジェのユニティ・ダ・ビアタションに似たピロティを持つ建築がありますけれども、ピロティはちょっと心配です。
This earthquake was noted for its effect on piloty architecture. Its columns of reinforced concrete failed under the load from the superstructure during the ground motion. Here in Zagreb, I saw a building with a piloty, which looked similar to Unité d'habitation by Le Corbusier, making me worry a bit. Piloty structures are of concern.
中間階崩壊と呼ばれる被害もかなり出ました。左の写真のように、なもんですけれども、2つ建物が建ってますが、神戸市のシティホールです。新耐震設計基準で建設された超高層棟は被害がほとんどなく、ガラスも割れませんでした。旧基準で建設されていた庁舎の中間階の柱が崩壊しました。明け方の勤務時間前だったのがせめてもの幸いでした。
There was much of intermediate story failure in mid to high rise buildings. And to your left, you see the picture of two buildings, which are the City Hall of Kobe. The tower was constructed to the new code, which had very little damage. And even their window glazing were left without any breakage at all. However, the one built under the previous code, the lower one, had columns in the immediate stories failed. I would say a small consolation is the fact that it was too early in the morning the quake hit and nobody was in the office.
この神戸市庁舎は右の写真のように低層棟の上部を解体して再利用しています。
And on your right, you see the picture. This lower building is now again used by removing the failed upper stories.
このような被害も出ています。中間階の崩壊です。
So this shows another example of the failure in interstories.
鉄筋コンクリート像の柱張り接合部の被害も顕著でした。このことはかなり前から指摘されていましたが、大きな問題で、日本の建築構造研究者の多くがこの問題に取り組んでいます。
Also readily observed there was damage to column and beam connections in reinforced concrete buildings. This had been recognized as a big problem for some time, and many researchers in structural engineering are working on this challenge in Japan.
特に単柱と呼ばれる腰壁などによって柱が短くなっている設計が問題です。そのため腰壁と柱の間にスリットを設けるような設計が行われるようになりました。
It is especially prevalent among so-called short columns, or a type of design where columns are shortened due to the presence of a jack wall or the like. Recently, a slit or a cut is placed between a jack wall and its short columns to address it.
鉄筋コンクリート像における鉄筋のガス圧接による接合が一般化していましたけれども、引っ張り力によって切断された事例も見られました。
Until this earthquake, connections in reinforced concrete construction were typically by gas pressure welding of rebars. Some connections were torn apart by tensile force.
鉄骨造でもさまざまな被害が出ました。設計の仕方も施工の状態も問題だったのかもしれません。
Steel construction also received different types of damage. Both design or construction issues were possible causes.
芦浜高層住宅プロジェクトという1978年頃に建設された国家的プロジェクトの集合住宅です。柱が引っ張り力によって切断するという被害が出ました。大きく傾いたんですね。この建築は鉄骨のスーパーストラクチャーの中にプレキャストコンクリートパネルによる壁式の中層集合住宅をはめ込むという画期的なものでしたけれども、鉄骨に耐火被覆をしないという特殊な構造であったために柱が切断されているということが地震後に発見されました。
This is a multi-residential complex called the Ashiyahama High-Rise Residential Project, built around 1978 as a national project. We saw column failures by tensile stress. The project featured an innovative design where a mid-rise multiple residential building of bearing wall construction using precast concrete panels is placed in the steel superstructure. It also featured a very sophisticated use of steel members without encapsulation, allowing us to discover severed columns like this.
木造住宅にもたくさんの被害が出ました。 応急危険度判定に関する研究が1981年から85年にかけてなされていたので、それが実際に適用されました。
Wooden houses were also very much affected. The study for damage classification of buildings had been conducted from 1981 to 1985, and it was actually applied in the field this time.
2000年には建築基準法が改正され、性能規定化が進みました。このことによって木造、鉄骨造、鉄筋コンクリート造などの構造種別ごとに全く考え方が異なっていた建築基準が同一の観点から判断されるようになりました。ただ、私から見るとまだ十分ではありません。
In 2000, the Building Standard Act was revised with more performance-based provisions. This was a game changer in the sense that different structure types are now assessed against the same criteria, a departure from the old system of type-specific regulations. My personal view on this, well, not enough has been done yet, in my opinion.
2005年には E ディフェンスと呼ばれる実物大の建築物を揺らすことのできる3次元振動破壊実験施設が完成します。実際に破壊に至る過程を観察することによってさまざまな知見を得ることができる装置です。これについては山崎さんが後で詳しく話しされるでしょう。
In 2005, a 3D destructive vibration test facility called E-Defense was completed. E-Defense is a facility where you can actually test full-scale structures to gain its knowledge by observing the actual process leading to a failure with your own eyes. And I believe that Ms. Yamazaki will describe it in detail to you.
このような研究のためには、地震波がどのようなものであるかを把握することが欠かせません。そのために地震動の計測も昔から進められていきました。大森房吉教授により大森地震計などが開発されます。120年も前のことです。
For these studies, it is essential to understand the nature of seismic waves and cycles. We have a long history of instrumentation research for seismic motion. One example I'd like to share with you is Omori seismic meter developed by Professor Fusakichi Omori more than 120 years ago.
そして地震の観測網も広がってきました。1995年には日本全国で258カ所であったものが2003年には1764カ所に設置されています。そして現在は2100カ所まで増えています。
The seismic observation network has also been steadily expanding in Japan. Back in 1995, we had a total of 258 monitoring stations across Japan and 1,764 in 2003, and today we have 2,100 stations.
応急危険度判定に関する研究は今も進められています。現在では衛星写真やドローンを用いた技術、そしてそれらの情報を迅速に集約する技術などの研究が進められています。
We continue studying damage classification even now. Utilization of new technologies such as satellite imaging or drones is ongoing, and the development of analytical methods of data collected by such new technologies are ongoing as well.
最近では伝統的な木造に関する耐震性能の研究も進められています。五重塔というのはとても昔から建設されているんですけれども、地震で倒壊したという記録がないんです。なぜ五重塔は倒壊しないのか、それを実際に揺らしてみて研究しよう、そんな研究も行われています。
I am happy to report that there is renewed interest in the seismic performance of Japanese traditional wooden construction. 5-story pagodas have been built in wood from ancient times in Japan, but there is no record at all of their failing in an earthquake. And why? That is what we are studying now by actually using the structure.
また、免震構造と呼ばれるゴムの支承で建物を支える構造なども増えてきています。地震発生時に継続的な利用が求められるお役所の建物や病院などに急速に普及しています。
We are also seeing an increasing number of buildings using seismic isolation systems, which are rubber absorber equipped support. Their adoption is spreading rapidly among government buildings or medical facilities, which need to be functional even during earthquake events.
さらに、レトロフィットと呼ばれる免震構造を取り入れることによる既存建築物の耐震改修なども進んでいます。この大阪市中央公会堂は1918年に竣工した100年以上前のレンガ造の建物です。それを浮かせて耐震的にしようとしたものです。
In addition, existing buildings are seismically upgraded by incorporating earthquake isolation systems. We call it retrofitting. This is a hybrid building of steel and brick masonry constructed back in 1918, that's 100 years ago, called Osaka Centar Public Hall. And we actually uplift the building and installed the seismic isolation systems.
そして2011年の3月に東日本大震災が発生しました。皆さんもご存知だと思います。10年ほど前のことになりました。マグニチュード 9.0 と言われる海洋性の巨大地震です。
Then came March 2011. It's the East Japan Great Earthquake. I am pretty sure that you are all familiar with it. 10 years has passed since then. It was a submarine megaquake reportedly of magnitude 9.0.
津波による甚大な被害が起きたことはニュースで世界中に知られることになりました。また、福島の原子力発電所が制御不能になったことも衝撃的なニュースでした。
The news of catastrophic losses by the tsunami flew through the world. Even more shocking was the news of the Fukushima nuclear plant out of control due to the tsunami.
東北地方を襲った東日本大地震では、鉄筋コンクリート造の被害はあまりありませんでした。建築物の耐震性に関してはそれほど問題なかったと言ってよかったと思います。
The East Japan Great Earthquake caused little damage to reinforced concrete buildings. I would say that there wasn't much of a problem with the seismic strength of buildings itself.
鉄骨造の被害もありましたが、それほど致命的ではありませんでした。しかし、津波による海水の圧力によって大きな被害を受けました。
Steel buildings did receive some damage, but nothing significant from the ground motion. But when they were hit by tsunami, they could not withstand the seawater pressure.
非構造部材、特に大空間の天井仕上げの落下が大きな問題となりました。その後、特定天井と呼ばれる一定規模以上の天井については、特別な設計をするように義務付けられました。
The failure of non-structural members was highlighted by this earthquake. In particular, large pieces of ceiling finishes fell off in long-spanned spaces. It was later mandated that ceilings of a certain size or larger be specially designed, which are now defined as designated ceilings.
東日本大震災では震源から 700km 離れた大阪市に立つ超高層ビルが激しく揺れました。長時間にわたってゆっくりと大きく揺れ続けたんです。建物は崩壊しませんでしたが大きな問題とされました。長周期地震動に対する考え方は現在も研究が進められています。
This East Japan Great Earthquake actually rocked skyscrapers in Osaka City, 700 kilometers away from the epicenter. These buildings swayed slowly for a prolonged period of time. The buildings did not collapse, but this rocking was identified as a major issue. Studies of such long period seismic motions are now ongoing.
2016年、今から7年前には、日本の西に位置する九州の熊本市で、熊本地震という大きな地震が起きました。 大きな揺れが2度起こって、2度目の方が大きかったということが特徴的でした。住宅に大きな被害が出たほか、旧耐震設計法で設計された建築にも大きな被害が出ました。
7 years ago, in 2016, the city of Kumamoto on Kyushu Island in western Japan was hit by the Kumamoto earthquake. It was unique in that there were 2 shock waves, and the second one was greater than the first one. Houses were extensively damaged, and so were buildings designed to the old seismic code.
この地震では応急仮設住宅の建設の仕方などが大変進歩しました。応急仮設住宅の考え方についてはこの後浜さんがお話になります。
This earthquake prompted the advancement of construction methods for temporary relief housing. I am sure Mr. Hama will speak to you about the approach to post-disaster temporary housing.
私のお話のまとめとして、地震の被害の経験が日本では今まで建築物の耐震性向上へ生かされてきたということが言えます。それとともに科学的、工学的知見の積み重ね、研究者たちの不断の努力が生きているのだと思います。
Now, I'd like to wrap up my presentation. I'd like to conclude that Japan has been turning its experience of earthquake damage to improve the seismic strength of buildings. Of course, it is thanks to the untiring efforts of researchers to build up our knowledge base with incremental learnings.
その背景には日本の建築教育の特殊性があるのかもしれません。多くの学生は建築の設計を行いたい、建築家になりたいと思って大学の建築学科に入学するんですけれども、自分は設計の才能はあまりない、友人の方がはるかにうまい設計をすると気づくんです。ただ工学部に属していますから数学物理ができるので耐震性能や構造設計の方法を研究している先生も多くいます。そして耐震性能の向上への道に進んだり、適切な耐震改修を行う技術者の道へ進んだりする人が多いんです。人材の育成が最も重要だということでしょう。
I wonder if it is the unique feature of architectural education in Japan behind all of this. Most students choose architecture as their major at university, dreaming of becoming an architect to design fashionable and famous buildings. But many soon realize, oh, I don't have any talent for this. Or, so and so is much more gifted than I am. And fortunately, the School of Architecture is a part of engineering department in Japan. And there are so many professors who specialize in seismic performance or structural engineering. And I am happy to say many students eventually choose to contribute to better earthquake resistance as researchers or to become engineers for seismic upgrading or design. So talent development is probably the most important and best thing to do for our efforts to prepare for and overcome disasters. So hooray to young researchers and students here in this hall.
It's my conclusion. Thank you for your attendance.
Thank you for interesting, great lecture. Floor is yours. Do you have some questions? No? One? Microphone is coming. I have to say, during the preparation of this seminar, we discussed about the things, comparison, Japan and Croatia, and we from Croatia usually looking forward to Japan like some ideal of organizing things, and you just showed that you are also were struggling during all that period, and we have to use to that and do our maximum in our country.
Sanda Kobovic from Montreal, Canada. Thank you very much for your super interesting presentation. I have one question to ask. We can see very well there is really an effort to put together engineers, researchers, industry, and you are very fast to implement all these new coming solutions to your everyday life. So I just wonder, how do you manage? Because I can see in many countries there is a lot of delay between, invention and then, codification and then implementing into industry, making clients understand that this is really the good thing to do. So I'm really impressed how very well does it go in Japan. So I was just wondering if you have some comments on that.
I'm not so good at hearing English, so I will listen to her interpret.
で、どうもエンジニアとか研究者の間で何かやったときにですね、その速やかに行動に移されているのが非常に印象深かったと。で、今やインターネットも随分と早く情報が流れるようになりましたけど、それでもどうしてもなんか発明とか新しいものが出た後で、それを実際に検証して使えるようになるまでの時間性、がどうしても出てきてしまうと。で、セッションに説明したとしてもそれが実際に使われるかどうかというのは、それをどうやってやってらっしゃいますか。まずplease, I speak in Japanese. まず地震が起きたら大学の研究者や建築研究所の研究者はもうすぐ翌日には、飛んでいって実際にどういうふうにものが壊れるかを見ます。でそれを参考に、次の、ステップに行きます。で大学の研究者は論文をたくさん書かないと評価されないですから、それも彼らのモチベーションになっているということは否めません。でももちろんその地震被害をみんなで減らしたいというのはやっぱり皆さん聞いてお分かりのように日本ではクロアチアでは100年に一遍だけど日本では10年に一遍起きているので、よりクイックにやらなくてはいけないですね。 Once an earthquake occurs, the next day, as the researchers or the people from BRI, Building Research Institute of Japan, we literally flew to the site and see the survey the damage to buildings, and then make that understanding, the knowledge for the next the research topics or the preparedness for the next earthquake. And at the same time, I would say that university researchers are evaluated based on the number of papers they write and publish, and maybe that's one motivation. But seriously, I must say that everybody is motivated, because here in Croatia, I understand that earthquakes is a 100-year event, but in Japan, it's a major quake happens every 10 years. So there is a real need and a desire to do something about it.
Is it clear?
Yeah, does that answer your question?
Yeah, thank you very much.
Okay, we will skip to, thank you very much. We will skip to next lecture. I am really looking forward to it from Kishimiro Hashimoto, I'm sorry. He is the president of Building Center of Japan, and I think that says everything. That speaks for itself. His experience in Ministry of Construction and numerous leading roles makes him ideal for giving us perspective of post-disaster reconstruction of Japan. Please, the floor is yours. This?
Okay. Thank you very much. Again, my name is Kimihiro Hashimoto. I am the president of the Building Center of Japan. I am here to discuss our responses to large-scale natural disasters in Japan. And I start my presentation with the background. Then I will explain firstly the historical development of the legal system for disaster response, and secondly, our approach to disaster response, and thirdly, the measures for post-disaster reconstruction. The first is preconditions or backgrounds. Just a minute, please. Japan is hit by a lot of natural disasters. The numbers shown in this figure respectively represent the numbers of deaths and missing persons in the past disasters. We have earthquakes, typhoons, heavy rains, heavy snow, and volcanic eruptions almost every year. And each of them causes human casualties and damages to buildings. Okay, just a minute, please. Maybe I skipped. Okay. Now I will explain the stages of disaster response. It is often said that when a large-scale disaster occurs, we consider 3 days, 3 weeks, 3 months as a kind of milestones. The stages shown here are described in a report of the lessons learned in the reconstruction efforts following the Great Hanshin-Awaji earthquake disaster, which occurred on January 17, 1995. The initial response is made during the first 3 days. In my experience, everyone prioritizes saving lives in front of him or her, and it is difficult to even grasp the whole picture of the disaster during this period. This is tentatively called as stage 1. Then, as the extent of damage becomes clear, provisions of shelters, setting up an emergency medical care system, securing communication means, and establishing transportation routes for goods take place over a period of approximately 3 weeks after the disaster. And at the same time, the construction of emergency temporary housing is started. This housing is for disaster victims to use for a few years. This is stage 2. Mr. Hama will explain this in detail later. Then, a reconstruction plan must be made, which should take place at around 3 months, though it took 6 months to make a reconstruction plan after the Great Hanshin-Awaji earthquake disaster, as it was a massive disaster. This is stage 3. Full-scale reconstruction period is called stage 4, and the period immediately before the occurrence of a disaster is called stage 0, or the disaster prevention period. Next is a legal system for disaster response. Now I will explain the legal system in Japan concerning response to disasters. I will go through them in chronological order. First, the Disaster Relief Act was enacted in 1947. This act was made to ensure victims are protected after a disaster event, but it did not cover post-disaster reconstruction, which means that this act was only for stage 1 and stage 2. Also, the act stated that the prefectural governors were principally responsible for providing relief to victims. This is still the basic approach today. The types of relief are defined here, and provision of shelters and emergency temporary housing is stated in the first item, and emergency repair of affected houses is in the 6th. Then, the Basic Act on Disaster Management was enacted in 1961. I believe that it would be ideal to have a Master Act first, and then various laws relating to each policy to follow. However, such does not always occur in Japan. Anyway, this act is to formulate a basic policy for necessary disaster control measures, including the disaster planning, disaster management, emergency disaster control measures, and financial measures concerning disaster recovery efforts and disaster management to achieve its objective. It covered stage 0 to stage 3. The basic principles are defined here. Firstly, measures for disaster preparedness are regularly upgraded to minimize damage caused by a disaster, and efforts are continuously made for improvements based on the lessons learned from past disasters. When a disaster occurs, the size of the disaster is assessed as accurately as possible, and human resources and distribute goods and other necessary resources are dispatched appropriately based on the situation. Priorities are to protect human lives and maintain safety. Also, critical services must be restored promptly to aid victims and initiate general recovery. Description of specific responsibilities and actions for each level of government is not covered by this new law. The Act has a provision for disaster recovery efforts, but there are no clear provisions for reconstruction of urban areas or housing. It was just after the Great Hanshin earthquake in 1995 when the Act for Reconstruction of Disaster-Stricken Urban Areas was enacted. This was the first act to cover stage 4. This is an example of urban areas in Kobe City having had a substantial damage. When reconstructing an urban area of substantial damage due to a disaster, and if individual construction initiatives are allowed in an uncontrolled manner, it may not be possible to plan and reconstruct the community to better resist future disasters. We already had and still have a law that makes it possible to restrict rebuilding, including restoration, in the disaster-stricken urban areas for 2 months. However, 2 months was too short to prepare a reconstruction plan and obtain consensus of the residents. Therefore, a new act was enacted to extend the period of this building restriction to 2 years for the areas subject to planned reconstruction. The Act was enacted in 1998, which grants financial support to disaster victims. Before this Act was created, no subsidies were available for repair or restoration of houses. This was based on the principle that restoration or reconstruction of personal property should be made through self-help efforts, and that it would not be appropriate to spend public funds for that. However, the Great Hanshin earthquake caused so much damage to housing, and there were a great many victims who were unable to reconstruct their houses on their own. That led to the creation of this new act. Under this act, those whose homes are totally destroyed are granted 3 million yen, around 22,000 euro, when they build or purchase a new house. However, this financial support is less than 1/10 of the amount required, as the average cost of constructing a detached house in Japan is around 35 million yen, or around 259,000 euros. Most of the disaster victims have rebuilt their homes through such self-help efforts, as taking out loans. Then the Great East Japan earthquake hit in 2011. This historical disaster led to the introduction of another act. This new law provides for the division of roles between the national government and local governments related to post-disaster reconstruction. As explained in the beginning, prefectural governors are principally responsible for providing relief to disaster victims in Japan. For reconstruction of urban areas and housing, both prefectures and municipal governments are involved. With this act, when a large-scale disaster occurs, the national government can make a basic policy for reconstruction and provide urban planning on behalf of the affected prefectures. The law also provides for the national government to restore infrastructure such as roads instead of the prefectures. There were 3 disasters to which this act was applied since 2013: an earthquake, a typhoon, and the flooding due to heavy rain. Next is the principles for reconstruction after disaster. Well, there are 2 concepts in Japan related to post-disaster response. The first one is restoration, which, of course, is to make things as they were before. The basic approach for roads and railroads is to restore them to their pre-disaster condition. The second one is reconstruction. The word reconstruction means to rebuild something that has been destroyed. For urban areas and housing, the approach is to rebuild them to better resist disasters, not to reproduce them to the pre-disaster condition. That is the build back better. As far as the restoration of housing is concerned, however, it is the responsibility of private owners. The national government may support them through the public financing or grant financial support for certain parts of restoration or rebuilding. However, in principle, individuals are responsible for their own homes. In addition, building regulations in Japan require that reconstruction or large-scale renovation of buildings conform to the building standards. Though existing buildings are not forced to be reconstructed simply because they don't comply with the current standards. This principle also applies to reconstruction due to disaster. Further, the goal is to rebuild the urban areas more resistant to disasters, which may call for additional restrictions on the buildings. Next is the procedure and the examples for reconstruction after disaster. This is a reconstruction and development project in response to the Great East Japan earthquake. It was undertaken by the Urban Renaissance Agency, we call UR, a quasi-government business operator established by the government for urban area reconstruction. For urban areas that were completely destroyed by the tsunami, residential areas were relocated far from the coast to be safe from future tsunamis. This was done by higher tide embankment and raised ground for the new construction. The UL completed the development of 1,314 hectares in 22 locations in response to requests from disaster-struck municipalities. Although the cost of reconstruction or repair of private houses are, in principle, borne by individuals, publicly operated housing for disaster victims is offered as rentals to those who can't afford to rebuild their own homes. The rent depends on the income of the tenant family. The Urban Renaissance Agency, UR, has also constructed such housing on behalf of disaster-struck municipalities upon their request. In general, when individuals reconstruct their own houses, they are eligible for financing by a government agency. The Japan Housing Finance Agency, a financial institution established by the government which provides financing for housing construction, offers loans at low interest rates. More favorable terms are available to disaster victims. However, a loan is still just that, a loan. In some cases, builders and housing companies cooperate together to support owners to reconstruct their houses. I explained an overview of the Japanese system for disaster recovery of urban areas and housing. There are several differences between Japan and Croatia, such as how natural disasters are dealt with or how social services work. The basic approach to the government's involvement with personal property may be an example. I sincerely hope that my presentation is helpful to you. Thank you very much for your kind attention. I need help. You could help.
Okay. Thank you. Lecture was really great. I think that notice between private and public is crucial for us. And I think there will be some questions. Here it's too. We have over 50, I think, YouTube spectators, and maybe they have some questions. Igor?
Thank you, Mr. Hashimoto, for a very interesting presentation. I have only one question about land readjustment plan. So do you always make urban plan before reconstruction of some part of town with special and urban planners, or you sometimes only just substitute buildings with new ones? Thank you.
Okay. いつも災害が起こってから慌てて計画を作るというのが状態です。
Honestly speaking, sorry, but every time the disaster hit, we have to scramble to come up with a plan.
Okay. Next. Okay. Next, please.
Hello, Mario Uroš from Faculty of Civil Engineering. Very nice presentation. Thank you very much. I would like to ask you one question about the reconstruction of the houses. I heard that the goal is that they should be better than before the earthquake. But which level of safety and how that you meaning the better than before? Or they must complain to the standard of in Japan?
前よりもよく建てなきゃいけないっていうのは前よりも安全に建てろという意味でか、それとも現在のその現行の建築基準に従わなきゃいけないという意味でおっしゃってらっしゃいますか？
もちろん現行の建築基準に従わなければいけないということで、ちなみに日本の建築基準は、巨大な地震でも生命財産が失われないということを基準に、基準を作ってますので、当然その新しくできる建物あるいは住宅はどんな大きいほど特別なのは別としてね、通常の考えうる災害に対しては 生命が守れるようになっているはずだということです。わかるかな？
And of course, they must be built to the current building standards. The current building code we have in Japan has been designed to protect life and property within the building under sort of a foreseeable earthquakes or disaster. Unless it is an extraordinary, it's something that we can't really think of type of disaster, the building should withstand the shock and also protect the lives within the building.
Thank you very much.
Okay, thank you.
Okay, we will have now short pause. Outside it's coffee, little snack, water, and we will be back in 3:05. Thank you. Okay. Okay. Can we continue? I can say the lectures were really good because discussion on the coffee was about lectures, not about something else. And I hope this will continue. We have a third our lecturers, Hirofumi Hama. He was holding and still holding so many principal positions what require many decision-making roles. And this is one of key topics in Croatia. Another key topic is emergency temporary housing, especially for my friend Hanžek. And please, floor is yours.
皆さんこんにちは。
Good afternoon, ladies and gentlemen. Oh, sorry. Good afternoon, ladies and gentlemen.
ただいまご紹介に預かりました浜博文です。
I'm Hirofumi Hama, and thank you very much for the kind introduction.
本日はこのような機会をいただきまして、誠に光栄です。
I'm honored to have this opportunity to speak to you today.
2020年にはここザグレブで大変大きな地震があったというふうにお聞きをしております。被害を受けられた皆さんに心よりお見舞い申し上げるとともに、復興にあたっていらっしゃる方々に敬意を表したいと思います。
I understand that in 2020 you experienced a large earthquake here. And I'd like to offer my sincere sympathies to those who have been affected, and also a salute to you here in this room for your efforts for the recovery of such a disaster.
私の資料は簡単ですけれども、実例を皆さんに、見ていただければなと思っています。深尾先生、それから橋本理事長から私の名前が出まして、そこでちょっと聞いてまして、大変今ドキドキしております。
And my presentation will be a simple one, but I'd like to show you actual examples of what we have done. And I was listening to the presentations by Dr. Fukao and Mr. Hashimoto, and I'm a bit nervous because they touched on the topic of my presentation as well.
よろしくお願いします。
Thank you.
私が所属する大和ハウス、それからプレハブ建築協会の概要は資料を見ていただければというふうに思います。
Please refer to the information material that has been distributed for Daiwa House Industries, the company that I work for, and also the Prefabricated Construction Suppliers and Manufacturers Association.
プレハブ建築協会は会員数が227社あります。災害対策の事業として応急仮設の建設および関連技術の調査研究を行っている協会です。
And the association has a total of 227 companies in its membership, and we work on the disaster preparedness and the mitigation, and especially the construction of temporary relief housing.
早速本題に入ります。最初は日本における自然災害と応急仮設の近年の事例です。 深尾先生にもの講義にもありました3つの大きな地震について説明したいと思います。
So this is the outline of my presentation, and the first one I'd like to touch on is the recent examples of natural disasters. And Dr. Fukao pointed out the 3 recent examples of earthquakes.
日本は地殻構造的に地震がとても多い国です。このようにプレートがいくつも重なり合っていることが原因だと思います。
Japan is prone to earthquakes because of geological conditions, and as you can see that we have the multiple plate or the crust meeting together.
それから近年は地球温暖化の影響を受けて、特に、降雨量が増えて雨による災害が非常に激甚化をしております。
And the climate change has been a major it's a factor for the natural disasters, especially it's a heavy rain for its flood.
応急仮説の歴史でいきますと、先ほど先生の話にも出ていた関東大震災、1923年の東京を襲った関東大震災の時に、すでに仮設住宅を作ったという事例があります。
And I'd like to focus on temporary housing, and actually we have a record that back in 1923, when the Great Kanto earthquake disaster occurred, we had a provision of temporary housing even those days.
1947年に災害救助法というものが作られまして、法律的に応急仮設住宅の位置づけがなされました。
In 1947, we had the formalized provision of temporary relief housing thanks to the implementation of Disaster Relief Act.
その後、1983年にプレハブ協会として初めて、応急仮設住宅を都知事の要請によって建てたというのが、これが始まりになります。
And it was 1983, the association had the first instance of providing a prefabricated relief housing at the request of the Tokyo governor at that time.
30年前ぐらいからの災害の一覧表です。ご覧のように毎年のように地震災害があることがお分かりになるかと思います。
And this is a list of major disasters that we have experienced for the 30 years or so, and you can see that almost every year we have a major either earthquake or a natural disaster of some kind.
1995年の1月の17日にマグニチュード 7.3 の地震が発生しました。阪神・淡路大震災という災害ですけれども、主に神戸市を襲った地震になります。
On January 17th, 1995, there was an earthquake of magnitude 7.3, which is called the Hanshin-Awaji Great Earthquake, that hit directly the city of Kobe.
亡くなられた方は6434人、そのうち5800人がいわゆる建物に潰された圧死ということです。
And the disaster produced the death toll of 6,432 people. And out of that number, 5,800 people lost their lives because they were crushed to death by their buildings.
被害を受けられて避難をされた方は36万7000人、家屋の被害は24万9000、25万棟に上ります。
And those who fled their housing and then evacuated to the evacuation center numbered 367,000 people in total, and then it's actually 250,000 houses were lost.
私はその時にこの辺りに 大阪のこの辺りに住んでましたけれども、建物に被害はなく、朝、会社にたどり着くことができました。
I was living at that time around here, and fortunately my house was left unscathed, and I actually made it to my office.
しかしながら、明るくなってくるとですね、こういった火事、それから、高速道路の倒壊、深尾先生の話にありましたビルの倒壊、家屋の倒壊などの情報が続々と入ってきます。
Once the sun rose and as the day has arrived, we started to learn that there was collapsing highways and it's pushed over or collapsed the buildings, and also it's significantly damaged, flattened houses.
この写真はですね、先ほど深尾先生の話にもありました、新耐震基準の家は建っています。こちら側は、旧耐震の木造家屋で、このような状況がこのような状況が見て取れます。
This picture really shows the contrasting condition of the house built under the new seismic code versus the houses that were flattened because they had been built to the old code.
この写真も同じです。
And this picture also shows the same thing.
このような災害の後、こういった、応急仮設住宅を建設をしました。
So after this disaster, so this is the picture of the temporary relief housing that was built.
2000年に入っても災害が続いていきます。
In the 2000s, year 2000, we see that the continuation of disasters.
2011年の東日本大震災の時はですね、地震による倒壊の被害というよりも津波により町や村が消滅するという衝撃的で記録的な大災害になりました。津波が押し寄せてすべてを流し尽くしていく映像がニュースで流れ、日本の国民全員が戦慄しました。
And in 2011, we had the East Japan great earthquake, and at that time, it's not only the earthquake itself, but also the tsunami hit the area, and actually it completely destroyed some cityscapes, and some municipalities were wiped out blank. And we actually saw the images of the tsunami washing away everything in sight, and it was really a shocking sight to everyone in Japan.
その後の救助、復興に世界各国の方々からたくさんご支援をいただきました。本当にありがとうございました。この場を借りてクロアチアの皆様にもお礼を申し上げたいと思います。ありがとうございます。
There was support and assistance flooding into Japan right after the disaster. I'd like to take this opportunity to express our sincere thanks to all of you.
津波、マグニチュードは 9.0、津波の高さは10メートルに及んでおります。この時亡くなられた方は1万5000人を超えております。ほとんどの方が津波の溺れ死んでいるという状況です。避難に遭われた方々は57万5000人、家屋の倒壊は40万棟を超えています。
The magnitude 9.0 was the size of the earthquake, and tsunami reached as high as 10 meters in height. And more than 15,000 people lost lives, and most of them died because of the tsunami. It was actually, they were drowned. And the number of people who needed evacuation, it reached 575,000 people, and 200,000 buildings were damaged.
津波のエリアはですね、この沿岸が津波エリアですが、沿岸 540km に及んでおります。ですから、ザグレブからドゥボルニク ぐらいまでの距離ということになるかと思います。
So the tsunami hit this area, and the shoreline is about 540 kilometers. So I would say that that is about the same distance between Zagreb here and Dubrovnik, right?
これは津波の映像です。ビルの小学校の上で助かった方々もいます。
So this is an image of the tsunami, and you saw children on the top of the rooftop of elementary school, and that's why they were saved.
これは翌日の映像です。
This is a picture taken the day after.
1週間ぐらいすると土地が乾いてきますが、もともとはこの辺に市街地があったということです。
So one week later, we start to see the drying of the land, but of course, this was a built-up area before the tsunami.
このような状態ですので、一日も早くこういった応急仮設を建設することが求められました。
Because of this devastated condition, we needed to build relief housing as soon as possible.
こちらは熊本地震です。先ほどの深尾先生のお話もありました。特徴的なのはマグニチュード 6.5 の28時間後に、本震と呼ばれるマグニチュード 7.3 の地震が来たということ。
This is about the Kumamoto earthquake that Dr. Fukao touched on before. And it is unique because there were two shocks, and the first one was a magnitude of 6.5, and 28 hours later, what we call the main ground motion at magnitude of 7.3.
特徴的なのは、その後余震がたくさんあったということです。したがって、救助や復旧に当たる人たちの安全を図るために、復興救助活動が若干遅れ、時間がかかっています。
And unfortunately, the disaster accompanied a large number of aftershocks. And in order to make sure that the rescuers and reconstruction workers to remain safe, the initial work was delayed.
こちらの地震では死者は50人ですが、被災者は18万7000人、地方都市にしては非常に大きな被害を受けたと言えると思います。
Fortunately, the death toll was only 50, but the victims numbered 187,000 people. This is a provincial city, so for this type of city, the ratio of the victims is pretty high.
こういった地震が通った後っていうんですかね、活断層のラインがはっきりと見えます。
As you can see that, shall I call it, is the remains or the footprints of the earthquake. You can see that damage is clearly marked.
新耐震のおそらく、アパートも潰れています。
This is actually the apartment building that was built to the new seismic code, but it received a huge damage.
こういった我々の作った、鉄骨のプレハブ住宅とともに、熊本では木造のプレハブ住宅もですね、建設されました。熊本は林業が盛んであるということも理由になっています。
So you see that these pictures include the prefabricated relief housing built of steel. Our company did that, and also it included wooden relief houses because the prefecture Kumamoto is the production area of forestry.
これは一覧表になっています。それぞれ3日から4日で通常、着工しています。最初の完成は16日、20日ですので2、3週間で、完成を見ているという状況です。
This shows typical, it's the timeline for the initialization of the relief housing project and its completion. So usually 3 or 4 days after the disaster, we start the construction work. And then it's 16 days to 20 days later, let's say that 2 weeks to 3 weeks, we will complete the first building.
それではこれから、災害発生から建設に至るフローを見ていただきたいと思います。
So I'd like to show you the workflow from the disaster occurrence to the completion of the relief housing project.
災害が発生しますと、被災を受けた方は一時的に避難所に避難をします。こういった堅牢な建物、あるいは小学校の体育館等安全なところに一時的に避難します。
Once a disaster hit, the affected victims move to the evacuation centers. Evacuation centers are usually designated solid buildings, or let's say something like a gymnasium of elementary school.
このような状態です。
So you see, this is the condition that they have to endure.
したがって、一日も早い復興救助が建設が求められます。
That's why there is a strong need and desire to build temporary housing as soon as possible.
災害救助法が発布されて、標準では20日までに着工となっていますが、実際には3日とか8日で着工できるように努めています。
Once the Disaster Relief Act is mobilized, the law itself provides that 20 days or less from the disaster to the start of construction. But in reality, we usually start the construction work within 3 to 4 days of the disaster.
完成までは標準工期で21日ですが、実際には13日あるいは12日で完成を見ているというものもあります。
So the standard time frame or the construction schedule is set at 21 days, but in reality, some are built within 12 or 13 days.
避難をされていた方が、応急仮設に入る、または、自宅に戻って再建をする、あるいは近年は、みなし仮設と呼んでますが、空いている安全な公営住宅とか民間の賃貸住宅の空き家に、移り住んでいただくというパターンになります。
There are 3 patterns for victims to get their housing. The first one is to get an allocation of relief housing. Number 2 is they would go back to their own homes even though they are damaged, and then reconstruct or rebuild their homes for habitation on their own. And recently, the third option is for the government to make available the vacant public housing or the privately owned rental accommodation.
仮の住まいですので、この後は先ほど橋本理事長の話にあった復興公営住宅あるいは自宅再建とそれぞれ進んでいくことになります。
The temporary relief housing is, as it says, temporary only. So after spending their time in this type of housing, people need to move back to their own home, to rebuild their own homes and go back to live there, or to get more permanent accommodation through public housing or the private rental accommodation.
我々、プラブ建築協会は、即時対応できるように、事前に応急仮設に関する協定を各都道府県と締結するようにしています。
Our association, the Prefabricated Construction Association, has been working with prefectures, and we have concluded the agreement with them before any disasters, so that we can mobilize our resources once a disaster hit without delay.
各都道府県から要請があって 初めて会員会社の中で準備をして、都道府県と締結をして、スタートしていくという流れになります。
So once a disaster hit, the relevant prefecture will contact us and make a formal request, and then as the members of our association who are ready to act right away will get into actual agreement with the prefecture and start the construction work.
このように事前に、建設できる能力の調査は欠かしております。常に準備しております。
We always update our database that shows the building capacity of our members.
応急仮設の使用ですが、低コストで、短い工期、大量供給が可能ということで、非常にシンプルなプランが、にしてあります。
And as far as the specification of such housing is concerned, we have three parameters. It has to be low cost and a short construction period, and it needed to be constructed in mass. So the specification is very simple.
クロアチアと同じように日本も気候が国内で変わりますので、それぞれの地域に合わせた、気候に合わせた準備をしておきます。
I understand that Croatia has a very varied topography and climate, and it's the same in Japan. So we need to pay attention to the local conditions.
実際に建てている建設されている仮設住宅の建設実例を見ていただきます。
Now I'd like to show you photos of the actual examples of relief housing.
効率を上げるためにおおよそ3つのタイプを準備しています。
In order to increase the efficiency of a building, we have three types of plans.
20平米、30平米、40平米ぐらいを考えていただければよろしいかと思います。
So let's say that 20 square meters, 30 square meters, and 40 square meters. These are three types.
車椅子の方に対応できるタイプ。
And we have a barrier-free design as well for wheelchair-bound people.
それから集会施設、集会ミーティング。
And then also community space as well.
それから福祉仮設、高齢者や介護が必要な方のための建設プランも準備しています。
And also social public service housing for the elderly or the disabled people.
上段は標準的な工期ですが、今日花壇の杭を打つところから完成までのビデオを準備しましたので、ご覧をいただければというふうに思います。
So there are two rows, lines you see. The top one is a standard construction schedule. But for the lower one, I actually prepared a video showing you from the actually the placement of piles, the foundation piles, to the completion.
出ました。音楽が入ってませんので、そのまま見てください。
Sorry, you know that the music is supposed to be on, but it doesn't. So just watch it, please.
こ これが1日目で杭を打っているところです。
This is the first day. It's pile foundation is laid out.
鉄骨の柱を立てています。
It's steel posts are placed.
で、外壁のパネルを貼ります。
Now the exterior panels are installed.
で5日目で屋根がかかるということです。
So the roof is on the fifth day.
6日目から内装、それから設備工事を行っていきます。
So mechanicals and the interior work starts from day 6.
間仕切りと設備が入って、
And the partition walls and equipment, mechanicals are
外交を
in.
整えて完成ということで、外交。
And then as the landscaping is done and then completed.
このような形で、東日本大震災、政府から3ヶ月で3万個という要請を受けて、ほぼ6月には達成をすることができました。
So for this East Japan great earthquake, the government requested us to provide 30,000 units of housing within 3 months. And we actually achieved that in June of that year.
皆様方もご経験があると思うんですが、応急仮設住宅等復興にはさまざまな課題困難もございます。
And I'm pretty sure that you share with me that there are issues and challenges in recovery work.
災害が大きければ大きいほど初動対応、特に現地に入ることが、インフラが途絶えて現地に入ることができない。それから自治体の方々も被災を受けられて、住民の方々への対応、ケアをするだけで、建設等の計画をする時間もないというような不眠不休の状態になります。
And the greater the disaster is, it's actually the later the initial action could take place, because it's if the disaster is so large, then it's very difficult to get into the area from outside. And the local government people, they themselves are victims. And they don't really have any time to plan for recovery, because they need to attend to the issues in front of them.
実は意外なことに、建てる場所をですね、災害が起きて、探すのがとても大変です。ですから事前によく計画をしておく方が早い対応ができるということになります。
You might be surprised to hear that, but it's actually that identifying the good building site for temporary housing is one of the most difficult issues. So it's very important to have the planning for such a housing before any disaster hits.
これは皆さん方もご経験があると思うんですけれども、そこで被害を受けられている方も寝る場所、食料、水がないという状態です。でしたがって、何千人という建設作業をするスタッフの泊まる場所、それから食料等の確保も実は大変苦労します。
And I think, I'm very sure that you know this problem, because as the victims are having a problem of it's getting shelter, food, and water. So when you need thousands of construction workers to be on site, and you have to actually prepare for the logistics needs of their accommodation and food.
もっとスピード感を持ってということで、我々が取り組んでいる事例です。
And I'd like to show you some examples of it's a speedier, more expedient response to disasters.
配置計画、今まで7日間かかっていたものを2日に短縮をしたと、これビームデジタル技術を使って短縮した事例です。
So this is an example of a site layout plan rationalized by the use of the latest technology. It used to take 7 days to do that, but now we shortened it to 2 days.
建設のタイプは決まっています。それから、道路等の使用もすべて事前に決まっていますので、これをプログラム化するということにチャレンジしました。
And now we have the types of layout. I mean, the floor plans have been set, and also the arrangement with the access roads have been set. So these parameters can be placed into a program.
2019年の台風による被害の実例です。
This is the actual example of a typhoon disaster in 2019.
実際に使った3D のビデオとビデオをちょっとご覧になってください。
So would you please? I'd like to show you the 3D video clip that which was used for this project.
緑豊かな公園内であったため、樹木の保存に配慮して配置を検討しました。
So the trees have to be preserved.
最終的に採用された絵案では、談話室の配置を団地の中央付近に計画することで、コミュニティの形成に配慮をしています。
And the layout was designed to promote the community building.
中古の間隔については、要望に基づいてゆとりを持って計画し、3D モデルでイメージを共有しました。
The buildings were laid
このよう
out
に
with more
動画プレ
space
ゼンに
between.
竣工後の住環境のイメージを伝えたことが承認の後押しになったと考え
At
ら
the
れています。
request of potential prospective residents, and then we prepared 3D images of the completion, and we believe that it helped to get the consent of the future residents for the plan.
実際に今見ていただいたモデルと建設されたものが、ほとんど同じであることが分かっていただけると思います。
As you can see, do you see any difference? This is the one shown in a 3D model, and the other the actually built.
我々が建設するものと、準備をしていただく自治体の方のスムーズな、相互理解が図られて、7日かかる作業が2日で終わったことは大変喜ばしいことだと思っています。
So the communication between the local government officials and yes, the community and us, the party to construct these buildings, they went very smoothly, and that's why we achieved the decision on the site layout plan within 2 days.
さらに問題点改善点を進めていきたいというふうに思っています。
And we are working to resolve any outstanding issues.
災害においてはですね、公的な支援も大変重要だというふうに思いますけれども、被災を受けている人、それから我々のような救助、応援をする人、それぞれがお互いに支え合って力を合わせていくということがとても大切ではないのかなというふうに感じております。以上で私の発表は終わりです。参考になりましたら幸いです。ありがとうございました。はい。
Here comes it's Mr. Hama's the takeaway for today's presentation. Of course, in disasters, the public support is needed and important. But in my experience, actually, the more important and valuable is the mutual support and understanding between the victims and us who provide support and assistance. Thank you very much.
ありがとうございました。
Thank you once again. There are some things we didn't want to hear from this presentation, but I think it's very, very good. Do we have some questions from the floor, or several of them? Mike is coming. Here it is.
Thank you. Victoria Zinchuk, Director of EBRD. I'm actually very glad that we did see what we saw, because it kind of questions the status quo here in Croatia. One specific question that I want to ask, what is the estimated cost of this construction, whether this is per square meter or per dwelling? Because, of course, the prices that you would quote for production in Japan are probably somewhat different from the European ones, but it would be still good to have an understanding. Thank you.
建物だけの値段でいきますと、救助法で定められている標準的な価格は、タイプ 1K タイプで、480万ぐらいだったかと思います。実際には、一旦聞いてください。420万ぐらい。
The standard pricing of the building itself, without any frills, it's just the structure itself. The law provides 4.2 million yen for type 1K.
はい。ただ、各自治体からの要望で、いろんな設備をさらに付加する場合は、さらに、追加料金をいただくことになります。
But if we are requested to add more, let's say the mechanicals or something else, then we are to request additional payment or cost.
よろしいでしょうか。
Okay, hi, hello, thank you for this really impressive presentation. It was really inspiring to see it, especially due to the circumstances here in Croatia. My name is Karla Pudar, I'm from Solidarna Foundation. And I was actually wondering what is the estimated period that people can stay in those houses, and what is the future of those houses? So after their permanent homes are reconstructed, what do you do with these lovely buildings? Thank you.
それからこれ皆さん入居者が出ていたとどうされるんですか。
一つ目の質問に対してはですね、このような状態から家族だけの部屋を持つことができて、ここから、自宅の、壊れた自宅の再建をしたり仕事に行けるようになりますから、皆さん大変喜んで、いただいているのかなと、安心して、暮らしてもらっているのではないかと思います。
And so you see, they have to start from here to temporary housing where they can actually have a privacy with their own families. And then they can just commute to their work, or they can go to their own home to check it out. So I think I feel that the inhabitants they do feel it's comfortable, or at least they feel secure in the housing that we provide.
2つ目の質問に対してはプレファブリケーションですので、使える鉄骨、それから、使えるパネルは、リユースしていきます。
So for the second question, these are all prefabricated buildings, and therefore, once they are dismantled, for instance, steel columns can be reused, and any other members that can be used again are used for other buildings.
Just a short question. You presented the prefabricated family houses. Do you produce prefabricated schools or other types of buildings?
今住宅でしたけど、学校とか、
はい、はい、はい。作ります。作ります。例えば学校も作りますし、それから、COVID-19 の時の、いわゆる入院施設、そういうものも作ったりします。もともとプレハブっていうのはですね、日本で人口が急激に増えていく時代に小学校が足りなくて、教室が足りなくて、小学校をプレハブの教室をたくさん作ったという実績もあるくらいです。
Yes, of course we do, and we do provide prefabricated school buildings. And for instance, during this COVID-19 crisis, we actually built temporary medical facilities for hospitalization of patients. And as a matter of fact, prefabrication, building systems were developed rapidly during the explosive population growth that occurred after the war in Japan. Suddenly we had a swelling of school children. So elementary schools didn't have enough classrooms. So we provided prefabricated classes for schools, and that was done in our industry.
災害の時の仮設住宅はスピードを重視するので、ワンストーリーですけれども、1階建て平屋ですが、例えば小学校を作るということになれば、工期は長くなりますけど、同じ工法で、プレハブ工法で2階建てのものを作ることも可能です。
And for this type of temporary housing, we need the speed as one of the most important factors. That's why we have only one-story buildings. But for schools, we can actually use the same prefabricated construction method to build 2 stories.
Thank you. I have one question for you too, sorry. How many preparedness activities? We saw on presentation many preparedness activities between earthquakes. Can you point out what are most important for a country like Croatia?
その地震の間にいろいろとね準備をされたみたいですけど、クロアチアみたいな国にとって何が一番大切ですかね。
Hard one, yeah. 難しいですね。難しいですね。昨日被災を受けた建物を拝見させていただきました。日本でもすべての災害で仮設住宅が建つということはありません。
So yesterday I had an opportunity to actually observe damaged buildings in the city. And I have to tell you that in Japan, every disaster, we don't build temporary relief housing for every disaster that occurs.
今日ご紹介したのは、阪神の場合で、神戸市の約 15% の人、それから津波の受けたエリアですと住民の半数、それから 熊本地震でいきますと、熊本のシティの広いエリアだとやっぱり 15%、写真に写っていた益城町という町ですと、やっぱり 50% ぐらいの人が、被害を受けていることになります。でそういう大きな、災害というのは、日本でも10年に一度ぐらいで、したがって、マグニチュード7というような、あるいは住民の半数近くが被害を受ける、もし被害を受けるような、災害が起こったら、どういう準備をしていくのがいいのかという、ことを考えておくことがいいのではないかと思います。
So the examples that I showed you is, for instance, that the city of Kobe, at that time, 15% of the residents were affected. And for that tsunami disaster, it's actually 50% of the residents had some kind of damage in the buildings. And then also the Kumamoto city's case, 15% of the residents were affected. And when actually the picture that I showed you is from the community called the Mashi Township. And at that time, I mean, this township had 50% of the residents needed to evacuation. So this type of large disaster occurs even in Japan every 10 years or so. So I would say that you need to be prepared. Even though it hasn't occurred to you before, you should be, be proactive. Think of what would be needed if a magnitude 7.0 or the disaster that hit 50% of your population would be affected. You know, it's, that I think is important.
Yeah, and our last lecturer today is Ritsuko Yamasaki Honda. She is Deputy Director, General National Research Institute of Earth Science and Disaster Resilience. Her career is filled with DRR activities and DI framework, work with different ministries, administration, what makes her ideal to conclude this seminar. I have to say I enjoyed our late and early meetings because time difference, and you will present us Japanese disaster risk reduction efforts from Sendai framework. Please.
Thank you, Dr. Atarish, and without your support, and this seminar cannot be realized. And thank you very much also on Croatian Center for Earthquake Engineering, Faculty of Civil Engineering, the Building Center of Japan. It is my great honor to be here with you to present Japanese experiences toward disaster resilience. As shown in the previous presentations by Professor Fukao, Mr. Hashimoto, and Mr. Hama, Japanese are living with natural hazards. We, particularly as government officials, always take into account possible disasters for decision and policy making. Sorry. Okay. So my presentation will give you a different angle to explain Japanese DRR efforts. And this slide shows overview of my presentation. And first, I'm going to quickly overview the Centar framework and introduce Japanese efforts from NID. And I worked in UNDR from 2016 to 2019. After the adoption of the Centar framework, in charge of the monitoring and the implementation of the Centar framework, and I worked as a liaison of SDGs monitoring. I compare the four priorities of Centar framework with the Japanese DRR efforts. We are on learning process, and some attempts were successful and others not. So your views and inputs would be greatly appreciated to make our countries more resilient. So this slide shows international milestones of DRR together with sustainable development and environment. Although there are the different phases of DRR and the environment, so-called post-2015 global agendas, namely Centar framework, the 2030 agendas, including SDGs, and Paris Agreement, pose a challenge to these domains. In other words, if we work on DRR, you can also achieve sustainable development and tackle climate change. So why don't you work on DRR? This is my point. So as a target year of these goals are set in 2030, we are now in the midterm process, and they are written in the yellow part on the right side. This is a quick overview of the paradigm shift toward 2015. So a focus on disaster risk management, broader in scope, including man-made hazards, preventive focus, and outcome-oriented, and focus on economic losses by disasters. So the background of this is Hurricane Sandy in 2012. So the number of deaths are not big, but you know the disaster loss and the economic damage are quite huge. So this proceeds the paradigm shift. And so there are targets and the global indicators for the measurement. And again, they are working on the coherence. This is a quick overview of Sendai framework. The goal is to prevent new and reduce existing disaster risk, and thus strengthen resilience. On the right, on your right, and among the 7 global targets, the first 4 targets are outcome focused on disaster loss and damage. They are objective and measurable. Each target has greatly, the globally agreed indicators to be reported to measure the progress of the implementation of the Centar framework. So, okay. And there are 4 priorities of actions here. And before going to the detail of these priorities, I just want to emphasize that states have primary responsibility for DRR and share responsibility with the stakeholders. As Mr. Hashimoto explained, and this principle lies in the Disaster Relief Act in Japan. Priority 1, understanding disaster risk. So data collection, monitoring, evaluation, science and technology will contribute to risk-informed decision-making and evidence-based their policies. Now, new risk landscape, as you've seen by the COVID-19, the risks are the compound, cascading, and the systemic. So, as the Centar framework stipulated, it is important to promote and improve dialogue and cooperation among scientific and technological communities as the relevant stakeholders, policymakers, in order to facilitate the science policy interface for effective decision-making in disaster risk management. So I think the Croatian Center for Earthquake Engineering is taking the lead in this area, for example, organizing this seminar. On the right, and there is an online Center framework monitor for member states to report their progress according to the targets by global indicators. This diagram shows there are indicators in measuring the 2030 agendas. So the target, as you can see, and the common indicators, the common targets and the indicators are used for these 2 important agendas. So now there is a Centar framework online Centar framework monitor in place, and I was in charge of this, and while I was in UNSDR. So countries are reporting the one time through the Centar framework monitoring system. So these data are sent to SDGs goal, so the SDG reporting. So this is, you don't need to work on double, so you just work on DRR. This is my point. So this is disaster loss, different types of disaster loss data sources. I just want to mention here that there are several disaster loss data sources, but national disaster base are recommended. According to your own purposes, any type of hazards can be collected. Again, Croatian Center for Earthquake Engineering should promote it. So priority 2, strengthening disaster risk governance to manage disaster risk. So it is important to mainstream and integrate disaster risk reduction within and across all sectors and review and promote coherence. I listed here the achievement by Croatia and extracted from a paper by Dr. Mikak. As for platform, you have at each level from national to city level, and since you have their strategies, I think you are already in place, and I'd recommend you report it to the Centar Framework Monitor so that everyone knows your progress. So I got this graph is extracted from Sustainable Development Goals report, but originally from UNHCR. The number of countries are here for the national and there are strategies in place. And but 2021, I heard that Croatia reported 0. But now, if you have the strategies in place, please report it. So now I'm going to introduce where I'm working at the National Research Institute for Earth Science and Disaster Resilience, NIED. As you can see, and this is only one National Research Institute with focus on DRR attributed to natural hazards. So taking a multi-hazard approach, including earthquake, tsunami, volcano, heavy rain, flood, landslides, snowstorm, and avalanche. Almost everything, but not for the wildfire. So covering all phases of disaster management, prediction, prevention, emergency response, and recovery. And promoting science and technology for disaster resilience by interdisciplinary and transdisciplinary research approach. So this is our principle and co-design, co-production, and working with various stakeholders. This is another example of not limited in the NID itself, and there are several, 16 universities and institutions working on the DRR to promote science and technology by interdisciplinary and transdisciplinary approach, and using these measures. So another, sorry. So among their researchers, the initiative is quite interesting. So not only on the scientists and the natural science, and also social science and applied science and engineering here, and working together toward the disaster resilience from the every stage of disaster response, disaster risk management. So this is this explains how we can work with global communities. And JHOP is the network, and also working with IRDR, Integrated Research on Disaster Risk, and which is a decade-long research program co-sponsored by ISC, International Science Council, and UNDRR. And Japan established the National Committee and International Center of Excellencies, and working, this is a kind of two sides of coin, and we work both national and global stakeholders here. So now move on to the priority 3, investing in disaster risk reduction for resilience. As we already understand, it is impossible to precisely forecast the earthquakes, so rather invest prior to disasters. I prepared this for the definition of the resilience has been changed between the past 10 years. And so the red words are added from the 2009 terminology. As you see in the upper graph, and we call the resilience curve. So what we have to do is reduce the area of triangle. So rapid recovery and mitigating damage. So the example here I explained to you is this is the mitigation prediction efforts by Japanese government. So preventing tsunami caused mortality by early warning system, NNET. Yeah. It's developed in the yellow parts of Japan, and the big earthquake is predicted in the near future. So, so we have more than 2,000 observation stations around Japan for earthquake, volcano, and tsunami. So these information and the real time and data is transferred to the JMA to disseminate and earthquake early warning systems, and also this information is going to the train company and safety safety train operation. This is another example of swift recovery, the shared information platform for disaster management we call SIP4D. As is often the case, even if disaster data are collected on site, such data cannot be shared nor integrated for response actions due to restriction or administrative boundary, which hinders prompt action. Then we created a kind of a pipeline to collect the data and then deliver the information for actionable information to the different users. So the first one shows the both side cross view is supposed to open to the public. The other one is ISAT, ISUT, disaster response organizations. So they have more detailed and more personalized data. This is the closed one. So another example for prevention. So evaluation and disaster risk. So how we can implement this? So this diagram shows the case of landslides. In the cyberspace, we could do the simulation. In the physical, we have the real site experiment and also model tests at experiment facilities. Now I'm going to introduce two experiments of NIED. As Professor Fukao introduced, there is a 3D shake table called E-Defense. So this is built after the 1995 Great Hanshin earthquake and magnitude in 7.3, and caused more than 6,000 casualties. So this 3D shake table E-Defense, which can reproduce earthquake ground motion in 3 dimensions. As you can see, this table, the 24 table, and the displacement of 22 meters per second, and 2 meters in the double amplitude in horizontal direction, as well as a large area of 15 by 20 meters, that means 300 square meters. To demonstrate 3D shaking, 24 sets of actuator colored in blue, and 14 vertical and 10 horizontal, and 3D joint colored in gray into the test. These are selected research activities as accomplishment at E-Defense. So due to limited time, I cannot go into the detail, but from this experiment, we did for the seismic reinforcement to the couple of buildings, and also support this support the law by MLIT. Another example is by research collaboration with engineers, practitioners, and researchers. So as you can see, and these are full scale and the model. And the first test that's done for the full scale base isolated building like here. So this is a joint research. So if your engineers would like to work with us, and please let us know, and we could to do some joint research, and if our interests are met. So this is an example of RC school buildings with add-on reinforcement, 10-story RC building, rooms in base isolated buildings. And this experiment is not only for the structure, but also the inside of the room. This is also the inside of the room on the upper floors, and the upper floors are the more shaky. The second example, our facility is called large-scale rainfall simulator, the world's largest water sprinkling facilities. So this facility can give you the intensity of from 15 to 300 millimeter per hour. This is the highest record in Japan, but actually only the limited time. Not we don't have the hourly 300 millimeter, but it's really the downpour you can experience. So how these facilities are used for the social implementation. So these resilient technologies with large-scale simulator have these three. There are several types of experiments, but the typical one is landslide. And nowadays, we're using for the autonomous vehicle, and also drone and UAV. And then these the results are implemented in the guidelines and standardization and improved the resilient technologies. As you can see, we created these types of experiment inside of the simulator, and then use how the landslide will happen by the heavy rain. This is another example of the autonomous vehicle under the heavy rainfalls for the security, for the safety. Another interesting example is flooding houses and how the resilient, such kind of the new technology for the housing. The last one is priority 4, enhancing disaster preparedness for the effective response and to build back better in recovery, rehabilitation, and reconstruction. As seen in the previous presentations, Japan has learned from the past, reviewed problems, and then improved systems. Right after disasters, we are prepared for the next disasters together with the government, academics, and other stakeholders. So, as it's written in the Centar framework, DRR is everyone's business and essential to achieve sustainable development. And the important point is how to enhance transformative capacity for everyone. So, Fubaran, Van Pruno, and Croatia and Japan can and should collaborate together in fight for disaster resilience. Thank you very much for your attention. Sorry.
Thank you once again for presentation. It was the reason why we saved the lady for the end. You point up the main idea of our center to connecting all resources on one spot. Thank you for that. Do you have some questions for last presentation? One?
Thank you very much for your interesting presentation. Both yourself and also Mr. Hashimoto mentioned that one of the stages of important and good response is actually prevention, and the whole idea of this risk building resilience would probably be very important on that part. So I'm just wondering if is there a possibility to estimate, what would be the percentage of effort and money that is invested actually in this prevention type of part compared to disaster response, you know, and how does it evolve in Japan?
So thank you very much for your question. So you are asking how much money will save for the loss or something. But actually, there's no the detail of analysis of this, but according to UNDP, $1 saves the $7, 1 to 7. But I don't know, and nobody knows the source of this. So, and of course, we'd like to know on this, but as you see, and we have consecutively the disaster occurs. So, unfortunately, we don't know. But we believe and the pre-disaster investment will help us for the big disaster loss and damages. Thank you very much for your question.
First, to reflect to the first question, FEMA, the American institute, actually did some analysis, and they come to the conclusion that for the earthquake there was 1.1 return, and for floods and hurricanes up to 4 or something. So if you look for it, you can find it, but definitely there is hard data on it. My question for you was, we saw the platform that you had with a scientific institution on it, if I remember. I was wondering if you explain a little bit more about financing. Is it their everyday work, or are they finance some extra for their job?
Yes, and can you see the small figure here? Sorry. And so this is the National Research Institute, and the budget is from the government. Okay, my presentation is small. So about 12.9 billion Japanese yen, and it's about いくらでしょう? Can you calculate? Okay, here I did it. And 120 million US dollar a year. This is just a normal time, but if we can get the additional subsidy, we can get more. But this is the thing, and so we have more than 300 colleagues working in the research institute, and half researchers, half admin staff. I'll give you a brochure. And also there are brochures here and for the e-defense and some QR code and to take away.
This is the government-owned institute?
Yes, okay. National Research Institute. So thank you very much.
This is for all of you who stayed to the end of this seminar. This will be now, we are entering concluding remarks, and I will, it's some kind of agreement, I will call 2 ministries and our president of our chamber to say some concluding remarks. Please, Mr. Potresno, can you start first?
Thank you very much. Thank you for very interesting presentation from the Japanese experience. On behalf of the Minister of Culture and Media of the Republic of Croatia, Mrs. Nina Obuljen-Koržinek, I would like to extend our gratitude to the Ambassador of Japan to the Republic of Croatia, His Excellency Mr. Iso Masato, as well as to our hosts at the Faculty of Civil Engineering of the University of Zagreb for this unique opportunity to learn about the experience of renowned Japanese experts, thank you, in post-earthquake recovery. Thank you very much, Mr. Fukao, Mr. Hashimoto, Mr. Hama, and Mrs. Yamazaki Honda, for these valuable insights from your respective fields of expertise. We heard about many issues related to the post-disaster experiences, lessons learned, continuous development of anti-seismic regulations and standards, post-disaster reconstructions, as well as importance of technology and organization of temporary housing, the importance of disaster risk management as well as disaster risk reduction. We have experienced in Croatia almost all of these issues related to the earthquakes in last few years, but we still have a lot of work to do to improve our procedures. The Ministry of Culture and Media, more precisely its Directorate for Protection of Cultural Heritage, has been responsible for vital tasks across several stages in the post-earthquake immediate response and long-term recovery related to the domain of the Ministry's competence, which is the protection of immovable, movable and intangible heritage, cultural heritage. The immediate response included damage assessment through fieldwork and inspection to determine the level of damages to cultural heritage buildings and their valuable inventory in cooperation with further actors, primarily with the Croatian Earthquake Engineering Center, Faculty of Geodesy, Architecture and Civil Engineering and Planning, Croatian Restoration Institute, and so on. So the interdisciplinary approach is very important, as we know, in such situations and as we have seen from the Japanese experience. Also, the Ministry of Culture and Media has also been in charge of prescribing and monitoring the implementation of the most urgent protective measures, ranging from structural consolidation of heritage buildings to evacuation or in situ protection of movable cultural heritage, such as museum collections and sacral inventories. As you are well aware, the process of renovating cultural heritage buildings can certain specific challenges, mainly when it comes to balancing the demands for the structural safety of heritage buildings and the demands to protect their properties, defining them as cultural heritage. Another challenge is the labor shortage of highly specialized experts and are licensed for conservation and restoration work. However, we have not been alone in this demanding process, and the international support and exchange of ideas have been highly beneficial. In 2021, the Ministry of Culture and Media founded the Expert and Advisory Committee for the Structural Renovation and the Architectural Heritage in the earthquake-stricken areas of the Republic of Croatia, an international advisory body gathering Croatian experts in the fields of structural and seismic engineering, architecture, art history, as well as foreign experts specialized in seismic engineering and structural retrofitting to build heritage. In October 2021, the Ministry of Culture and Media received a donation from the Japanese Challenge Company, enabled through joint efforts to the Croatian Commission for UNESCO and the Embassy of Japan to the Republic of Croatia. The donation included EQ Guard seismic equipment for early detection of earthquake, and I would hereby like to conclude my comment by once again expressing our gratitude for this donation. Thank you very much.
Thank you, Mr. Petrinec. I would like to call representative of Ministry of Physical Planning, Construction and State Assets, Mr. O'Clair.
Ladies and gentlemen, on behalf of our Minister Paladina and Ministry of Physical Planning, Construction and State Assets, I would thank lecturers from Japan for coming in Zagreb and sharing their knowledge with us. Also, I would thank Her Excellency Ambassador of Japan and organizer HCPI for their today's excellent meeting. It will be a nice practice to regularly organizing seminars and roundtables meetings at all levels for experts and citizens. And why? First, for exchanging the knowledge, and second, to maintain the awareness about earthquakes and the need to reinforce our old buildings. Thank you all.
And we saved another lady for the end. Please, our Chamber of Civil Engineering, please try to conclude, overlap all this from expert view. Thank you.
Your Excellency, high guests, dear colleagues, I would like to greet you in behalf of Croatian Chamber of Civil Engineers and myself. I would like to thank distinguished speakers who very clearly present and introduce us to the Japanese practice in the fight against earthquake. From the government role in reconstruction after the earthquake to examples of construction of temporary housing facility and reconstruction of damaged building to development of the seismic code and legal system for disaster response, presentation of the typical damage of structure, special measures for the reconstruction and urban planning, and how to deal with the disaster risk management and reduction at the national and local level. Their experience is valuable to us, especially if we bear in mind that every few years Japan is hit by the devastating earthquake. Examples of the large earthquakes that have recently happened around the globe show that even when we are well prepared, great disaster can happen. What Croatia can and must learn from our colleagues from other countries is how to prepare in the best manner possible for the potential disasters, such as devastating earthquakes that struck Croatia recently and which once again warned us of the extreme importance of the safe and quality construction buildings, all in accordance with the applicable seismic regulation. For the building constructed in this manner proved to be safe for the people in very strong earthquake, it did not suffer significant damage. Finally, I would like to remind you that the Chamber of Civil Engineers submitted a proposal to the government of the Republic of Croatia to urgently from emergency engineering service as a part of civil protection system, which would be managed by the educated structure engineers. Such emergency engineering service in the events of the new earthquakes as well as other national disasters will be ready to act immediately as well as organize dispatch teams for activities in this area affected by the earthquake or other national disaster. Croatia Chamber of Civil Engineers has been involved in the elimination of the consequences of two devastating earthquakes from very beginning. We permanently organize education of our members to improve knowledge and skills in seismic engineering and methodology. Our expert teams also were involved in the changing of the existing code and the part of legislation to improve the seismic strength of the building. And in the end, thank you once again for the participating in this extremely useful exchange of knowledge and experience, with which the Croatian Earthquake Engineering Center continues to raise the level of knowledge and awareness of the risk of earthquakes. Thank you.
Thank you. We need fourth, because everything here is in relation to number of fourth. We have 2 deans, 3, 4 Does anybody wants to speak up something? No? Okay, I will not tire up you anymore. I will try to close and leave you this afternoon. We had around 150 people in this hall and about 50 people online on YouTube, and we sent a link all around the region to Macedonia, Serbia, Bosnia and Herzegovina, and Slovenia. And I have to point out that we were last week in Earthquake Engineering Conference in Romania, in Bucharest, and on several occasions we listened how Italia and several other countries gathered all that forces in some consortium inside the country, trying to do something in preparedness way or something in post-disaster activities, and we inside this center we are trying to do the same. I think we can gather up in this fight against earthquake, and this event today arm us a little in knowledge and sharing experience with our Japanese colleagues. Once again, thank you all for presentation, and I hope this is only start of our collaboration, and maybe the first one next is our conference. We have a conference in March next year, and we will looking forward to see you there. Thank you all, and see you